Hi, Assalamualaikum, and a very good morning, I guess, everyone. So, today we are going to continue with our tutorial class for this week. So, we are going to continue with chapter 5 again, states of matter, but this time we are going to look at unit 5.3, solid. So, we have learned about the properties of gas, liquid, so now we are going to look into solid phase. Okay, so there are a few learning outcomes that we are going to cover for today. The first one, we are going to explain the fixed shape of the solid. Next, we are going to apply the kinetic concept to explain the following process of freezing, melting, sublimation, and deposition process. Next, we are going to differentiate between the amorphous and the crystalline solids, and we are going to state the following types of crystalline solids with appropriate examples. So there are 4 types of crystalline solids that we are going to cover for today. There are metallic solid, ionic solid, molecular covalent solid, and giant covalent solid. So without further ado, let's get started. Okay, so first we are going to look at the properties of solid. So there are a few properties of solid that we are going to look at today. So the first one, we are going to look at the arrangement of the particles. Okay, so for the arrangement of particles for solid, the particles are closely packed together, and they are held in rigid and orderly arrangement, which means that they will be arranged very closely like this and in orderly arrangement. Okay, no space between them. Okay. So next we are going to look at the molecular motion. Since the arrangement of particles is very rigid and closely packed together in an orderly arrangement, so the solid particles are unable to move freely. They can only vibrate and rotate about fixed position. So they will only rotate between the fixed position lah. They cannot move freely like liquid and gas. Okay, and since these solid particles are in a rigid and orderly arrangement, they have a very fixed shape and volume. And the density for solid is very high. And solid cannot be compressed or cannot flow like liquid. So there is no compressibility and viscosity for solid. So these are the 5 properties of solid that you need to understand and aware. Okay, so next, we are going to look at the summary of phase change. And we are going to highlight the phase change that is happening in solid. Okay. So this is the summary of phase change between the 3 phases, which is between solid and liquid, between solid and gas, between liquid and gas. Okay, however, we are going to highlight the process that include or involve the solid phase, which are freezing, melting, sublimation, and deposition. So there are 4 processes that involve solid in the phase change. Okay, so let's get started into learning these 4 processes. Okay, so now we go into the first process, which is freezing process, or we call it solidification. So what is freezing process or solidification? So freezing process is a process in which the substance change from liquid to solid phase. Okay, from liquid to solid is called freezing process. So now let's see how does freezing process happen. Okay, first of all, when we are going to freeze something, we are going to put the substance in a low temperature room. For example, freezer or refrigerator, but most commonly freezer lah, because freezing kan, we want to change it from liquid to solid phase. We are going to put, for example, water inside the freezer. Okay, So, the process of freezing happens when the temperature of the liquid is lowered, like we're cooling it inside the freezer, for example. When the temperature of the liquid is lowered, the kinetic energy of the liquid particles decreases. Because it lose heat, right? Because when it lose heat, the kinetic energy decreases. Okay, so what happens when the kinetic energy decreases? So the liquid particles vibrate at slower rate. So makin lama dia akan move slowly dan dia akan vibrate at slower rate. So what happens next? So a point is reached when the intermolecular arrangement forces are strong enough to hold the particles together in a fixed and orderly arrangement, which is solid lah kan, betul tak? So when these liquid particles reach a point where the intermolecular arrangement forces are strong enough to hold the particles together in a fixed and orderly arrangement, so that is when the liquid is freezing. Liquid is freezing from a liquid phase to a solid phase. So that is how the freezing process happens. Okay? So liquid change into solid. So now we have from water to ice. Okay. Now we are going to look at the melting process or fusion. Okay. So what is melting process or fusion? So it is the opposite process of the freezing. So just now, freezing is a process where the liquid change into solid. For now, melting process is a process in which a substance change from solid to liquid phase back. Okay, so melting, tadi freezing, liquid to solid, melting, solid to liquid. So now we're going to look at how this melting process happens. Okay. So, usually when a solid substance is heated, so when a solid substance is heated, for example, ice, we put inside, keluarkan ice tu from freezer and then put inside the room temperature. Dia punya temperature makin increase kan? So, when solid is heated or when the solid substance is put inside high temperature kan, solid particles will gain energy. So what happen when solid particles gain energy? They will be able to vibrate more quickly and energetically at its melting point. Okay, sebab dia dah ada gain energy from the heat kan, so dia punya kinetic energy increases, so they are able to vibrate more quickly and energetically at its melting point. Okay. Okay, so what happened next? So these particles now have enough energy to weaken the attractive forces between themselves. So these particles now have enough energy lah, so dah boleh move lagi laju kan, to weaken the attractive forces between themselves. And now the particles are therefore free to move kan, sebab liquid kan dia free to move right. So now we can say that the solid is changing into liquid. So that's how the melting process or fusion process happens. Okay? Alright. So now we're going to look at the third process. So the third process is very simple. It's a sublimation and deposition process. So a sublimation process is a process in which substance change directly from solid to gas phase without first becoming a liquid. So solid directly into gas. So this is what we call sublimation process. So for example, from iodine solid to iodine gas. Okay? Alright. So, what is the deposition process? So, deposition process is the opposite process of sublimation process. So, it's a process in which substance change directly from gas to solid phase. For example, from iodine gas to iodine solid. So, this is for sublimation and deposition process. It's very simple. Okay? Alright. Next, we are going to look at the types of solid. Okay, so there are two types of solid here that we're going to learn. Two main types of solid. There are many types of solid, but these are the two main types of solid, which are crystalline solids and amorphous solids. And we are going to look at the differences between these two solids. Okay, first, we look at the arrangement of particles for the crystalline solid. Okay, for the crystalline solid, the particles are arranged in a regular or orderly arrangement and have a well-defined structure. So, crystalline solid ni dia arrange in regular, repeating or orderly arrangement and dia ada well-defined structure. Cantik je structure dia. Okay, however, amorphous solid are arranged in a random or disorderly arrangement and have a poorly defined structure. So, structure dia sangat poorly defined or dia tak ada well-defined structure. Okay? So, now we look at how does this solid form. Okay, for crystalline solid, it is formed when a saturated liquid is cooled slowly. So, when this liquid is cooled slowly, it will form a crystalline solid. However, when the saturated liquid is cooled rapidly, it will form amorphous solid. Amorphous solid with a poorly defined structure. Okay, so now let's look at the example of the crystalline solid and amorphous solid. So for crystalline solid, we have salt, for example, diamond, graphite, sugar, and metal. So these are the example of the crystalline solids. So this crystalline solid, for example, they have a regular and orderly arrangement of particles. However, the example for amorphous solid are charcoal, rubber, glass, and plastic. So these are the examples for the amorphous solid. So these are the differences between the crystalline solids and amorphous solid in terms of the arrangement of particles and the formation of the solid. Okay, I hope that you will understand this chapter. Okay, this subtopic is quite easy compared to the liquid and gas punya subtopic. So I hope that you can grasp this knowledge about solid rather easily than compared to the liquid and gas, because this is very easy. Okay, now we are going to look at the types and properties of crystalline solid. So under crystalline solid, there are few types of crystalline solids. Okay, for crystalline solid, there are 4 types of crystalline solids that we are going to learn. The first one is ionic solid. Second one is metallic solid. Third one is molecular covalent solid, or ada lagi satu atomic covalent solid. But dia punya properties lebih kurang sama je dengan molecular covalent solid. Cuma bezanya itu in a atom punya level, yang ni molecule punya level. And lastly kita ada giant covalent solid. Okay, so ni lebih kurang macam ada juga yang atomic atomic covalent solid. Dalam lecture note ada kan? Okay. But kita akan tengok yang this forming lah. Okay, sebab ikut dia punya learning outcome kita. Okay. So now we are going to look at all these 4 crystalline solid. How it formed, what is the properties of the solid, and what is the structure of the solid. So without further ado, let's get started. Okay, so let's look at the ionic solid first. So, ionic solid is formed or is consist of cation and anions that held together by strong ionic bond. So, ionic solid is consist of cation and anion that held together by strong ionic bond. For example, sodium chloride, potassium bromide. Okay, apa lagi? Banyak sangat. Okay, contoh-contoh ionic solid ni. Mostly salt lah kan, ionic solid kan. Okay, so this is the example of the structure of the ionic solid. It consists of cation and anion. They held together by a strong ionic bond in this form. Okay, dia ada cation and ion, cation and ion berselang-seli. Okay, berselang-seli dalam bentuk macam ni lah. So, this is the structure of the NaCl. Okay, this is the structure of NaCl. This is how NaCl is formed. Okay, this is a crystalline solid which is ionic solid. Okay, let's look at the properties of ionic solid. So, ionic solid is hard and brittle and have high melting point. However, it is poor conductor of heat and electricity in a solid state, but it conduct electric and heat in a molten state and aqueous solution because it has this free moving ion. So, this free moving ion are able to transfer the electric or the heat from one part to another part of the solid. So, that's why it can conduct electricity and heat in the molten state or aqueous solution. Tapi, dalam solid state, salt or this ionic solid cannot conduct heat or electric. Okay? So, bear that in your mind. So, in general, kalau dia dekat solid state, this ionic solid, poor conductor of heat. Okay? Because we learn about solid, right? So, in a solid state, ionic solid is a poor conductor of heat and electricity. Bear that in your mind. Okay, now, we are going to look at the molecular covalent solid or ada juga atomic covalent solid. Okay, tapi dia orang punya tu sama je. Okay, so molecular covalent solid is a molecules held together by intermolecular forces which are van der Waals forces such as London dispersion forces and dipole-dipole forces as well as the hydrogen bonding. So for example, we got water, oxygen gas, S8, SO2, C4H10. These are the example of the molecular covalent solid. So these are the structure of the molecular covalent solid. Nanti dia boleh gabung-gabung lah dengan ada water molecule, ada carbon dioxide molecule for example. Okay. So, what is the properties of the molecular covalent solid? So, molecular covalent solid is fairly soft. Tadi, ionic solid, dia hard, right? Dia hard. Kan, dia hard and brittle. But for molecular covalent solid, is fairly soft. And it has low to moderate melting point. Compared to ionic solid, it has high melting point. However, molecular covalent solid, it has low to moderate melting point. And molecular covalent solid also is a poor conductor of heat and electricity. Okay? Alright. Now, we are going to look at the giant covalent solid. Okay, for giant covalent solid, atoms are held together by strong covalent link and form network. Okay, beza je dengan yang regular molecular covalent solid ni. Giant covalent solid ni, dia held by strong covalent link and form network. Dia ada network dia. So, bila network, contohnya seperti diamond, graphite, silicon dioxide. Okay, for example. So, this is the structure of diamond. Dia macam ada bentuk tetrahedral ni kan. Dia tetrahedral and then dia macam water molecule yang ice tu kan. Diamond dia susun macam tu lebih kurang. Okay, dia ada form network of covalent bond. Okay, graphite pula dia dalam bentuk sheet. Okay, carbon yang macam hexagonal macam tu dalam bentuk sheet and then dia akan ada van der Waals forces in between them. So dia pun merupakan salah satu giant covalent bond along with silicon dioxide. Okay, so what is the properties of this giant covalent solid? So giant covalent solid is very, very strong, okay? And it's very, very hard. Okay, and it has very high melting point. Okay, semua pasal giant covalent solid ni dia ada very depan dia. Sebab dia sangat hard and dia sangat ada high melting point. However, it is a poor conductor of heat and electricity. So these are the properties of giant covalent solid. So now we are going to look at the last types of crystalline solid, which is metallic solid. So what is metallic solid? So metallic solid consists of positive ions of atoms or metals held together by a surrounding sea of electron. Ialah metallic bond. Okay, so kita dah belajar metallic bond in chapter 4.5 kan? So metallic solid ni metallic bond lah. Okay, consists of tengok structure kat sini, dia ada metal cation surrounded by the sea of delocalized electron. So this is the metallic solid. Okay, for example, kita ada sodium, magnesium, aluminium, zinc, ferrum. Itu semua adalah metallic solid. And what are the properties of metallic solid? Dia ada soft to hard lah. Depend on the metal. And the melting point varies from low to very high melting point. And metallic solid is malleable and ductile, which means it can change its shape and can be drawn into a wire. And metallic solid is a very good conductor of heat and electricity. So kalau kita tengok, in solid state, between all these crystalline solid, only metallic solid je yang good conductor of heat and electricity. Yang lain semua poor conductor of heat and electricity. Kenapa? Sebab dekat solid state, diorang tak ada free moving ion. However, in metallic solid, they're surrounded by the sea of delocalized electron or ion, which able them to transfer the heat or electric from one part to another part. So that's why metallic solid is a good conductor of heat and electricity. Okay, so that is all about solid. It's very simple, it's very short and sweet. Okay, it's very easy to understand compared to the other subtopic that we have learned previously, and I hope that you can really understand this chapter. Okay. So, for now, what you're going to do is seperti biasa, you have to jawab quiz chapter 5.3. Wajib jawab. Okay, please scan this QR code and answer the question. I have only 6 questions for you. And it's a very simple and easy peasy punya question. I hope that you got full mark for this. Please got full mark or like, please above 50% lah. Janganlah bawah 50%. Okay. Because this chapter is very easy. Okay, please read carefully before you answer the question. Jangan jawab sekadar jawab. Okay. Okay, you have to answer this quiz because this will be your attendance for today's tutorial. So, siapa yang tak jawab, saya anggap tak hadir. Okay, so yeah. I think that is all for today's tutorial. We are going to meet again for in tomorrow's tutorial, and we're going to finish chapter 5 for tomorrow. Okay, untuk esok kita akan habiskan chapter 5 because next week we're going to enter the new chapter 6, chemical equilibrium. Okay, I think that's all for today. I hope that you enjoyed this video and I hope that you will understand this chapter. Yeah, thank you for listening to this video and bye.